Hello, everybody. I will start my today's another coding practice. So today's video is about this meeting rooms number 2. So in this question, I'm giving an array of meeting time intervals where each element of intervals list is start and end tuple, and I will return the minimum number of conference rooms required. Okay. So let me clarify the question statement first. So in this question, I will be giving an array of meeting time intervals like this. And my task is to find the minimum number of conference rooms required. So I see. So as the input, I will be given the list of list, and each element should be the start and interval tuple. And then I will return the minimum number of conference rooms required. So I can think the number of conference rooms, I mean, to be required. I can think of it as the parallel number, max number of parallel meetings. So let me say if the meeting is 1 to 2 and 2 to 3, 3 to 4, then I need only one meeting because there is exactly, I mean, up to one parallel meeting at the same clock time. However, if the meeting is say 1 3 and 2 4, um, in the time from the time 2 to 3, there are two parallel meetings. So number of rooms required is 2. So it totally depends on the max parallel number, max concurrency, I can say. Okay, that being said, let me take a look at some examples. I will use this example. So if the meeting is like this, this should be 15 to 20. Then the number of rooms required is 2 because there are up to 2 parallel meetings. Yep, between time 5 to 10 and from time 15 to 20. So I should return 2. Okay, so that being said, let me think of the algorithm. So I think the brute force approach for this question is firstly, I will guess the minimum time, minimum start time. And also I will find the largest end time. And I will traverse each integer between the start and end. Then for every second, I will traverse all the intervals list. Then I will count how many meetings is there as the timestamp. And I will take a look at that concurrency for each time, each integer time. Then I will return the maximum of the currencies. Yep. This I can use this only if the meeting begins from integer timestamp and integer and timestamp. But it's true I can use that approach. But this could take so much time because assuming that the end time, the largest end time is quite large, I have to traverse until this much. So this isn't so efficient. I don't want to depend on that. Okay, so I will think of the better, optimized approach. So I think let me write some, examples. Yep. So in this case, okay. So what I should do from here is I will first resort intervals by the start time. And then until this one is ended, 1 meeting. And until this one is ended, there is one more meeting. So maybe I can sort it by the end time. Since that being said, so at this moment, there are 3 meetings with me. So no, it does work. So if I sort by the start time, okay, I see. So what I can do is a kind of what's the name of it? Line sweep. So if I'm given this from this time, maybe this should be say 0 and 20. Then at t0, count, or I should say concurrency is incremented by 1. And from t is 21, count is decremented by 1. So I can say this for each timestamp. So I will put all of them like this in the list, and then I will sort it by the timestamp. And after that, say I have 0 plus 1 and 1 plus 1. Yep. So in this case, sorry, at time 0, it should be 1. And time 1, number the parallel meeting rooms will be 2. Then in time 2, it is decremented by 1. So it will be 1. This means that one meeting ended at time 1. Then at time 5, the concurrency is decremented and it becomes 0. This suggests that there was a meeting which ended at time 4. Yep, that's it. So in this way, I will get the maximum number of the concurrency and then I will return it. Yep. But let me tell you about the case when there are some meetings which end at the same time. Like this. So in this case, this suggests that there are 2 meetings which ended at time 2, and there are 2 meetings which start at time 3. In this case, so I traverse the list. Okay, at the premise, I will traverse the tree and I will update current concurrency. Yeah, increment or decrement. So at time 3, it should be decremented first and then incremented first later. If I do increment first and then decrement later, like this, the concurrency should be first 3, 1, 2, then 1, 0. So 2 is marked as the max concurrency, but it isn't true. because negative one, plus one, all of them begins at the same time times 3. So I should do all of them at the same time and get the current concurrency. So the fortunate thing is that if negative 1 comes first, so if I sort it in ascending order, it should come first. And actually, current concurrency is decremented first and incremented later. So in the end, I can find the, I mean, you know, cancelled concurrency. So I don't, I mean, max concurrency is not updated with 2. Okay, that being said, let me get started with the implementation. So what I will do is I will outline and sort it. Okay, so this is the outline of the code. So that being said, I will start the implementation. So far I've finished first 2 items. So event list is created and then they're sorted. Okay. Yep. And I've finished last 2 items. So I traverse each event and I will take a look at this, and I will update the current concurrency with this diff. Then every time I update the current concurrency, I will update the max concurrency if it current concurrency is the maximum one. Yep. Then I will return max concurrency in the end. So that being said, let me walk through my code. Oh, sorry, I forgot to do the complexity analysis. The time complexity should be O of n log n. So basically, event list should have 2n events, and I sort it, so it takes 2n log 2n, which is n log n. Yeah, big O notation. Then after that, in line 37, I traverse each event, so it should take 2 times n, which is O of n. So in total, it should be O of n log n. And for space complexity, it should be O of n because event list should have 2n events. And sorting in line 43 should take O of n because Python uses a temp sort and it uses O of n extra space. After that, I don't use any space aside from the constant ones. So the space complexity in total should be O of n. Okay, so let me walk through my code quickly. So I will think of this example. So when I get this, the event array should be like this. Oh, let me take a look. So event is initiated with empty array and intervals. Then I will get start +1 and -1 -1. So I will take a look. It should be. Oh, wait a minute. So if the sorry. So if the event ends at time t, then I should decrement it at n +1. Because at the end time, the meeting room is still used. So I can decrement it at n +1 timestamp. Okay. Like this. Then I will sort it. So this should be like this. So now line 53 is ended. Then I will initiate current concurrency 0 and max concurrency 0. Okay. Then in line 62, I will traverse each event. So it should be taking a look at +1, +1, -1, +1, -1, -1 order. And every time I update the current concurrency in line 63, so this should be 1, then 2, then 1, then 2, 1, 0. And every time in line 64, I update the max concurrency with that. So in the end, this should be 2. So I will return 2 in the end. Okay. So I'm pretty confident on my code. So let me run it and then let me submit it. Good. Now it. Oh, wait. So it says there are 2 meetings. Wait, so if the meeting ends with times 13, it can be used for another meeting as next. So this means that the meeting room should be available from line 13. So I can say at the end time, the meeting room is already, available. So it should be end here, not end +1. Okay, so I will run the code again and then we'll submit it again. Okay, so now it's accepted. So one thing I can improve is that I should have asked about the end time. So one of the clarifying question I could ask is like, say if the meeting starts from 1 and then the 2, another start at time 2 and end at time 3, then does it need to conference rooms, or does it need only one? And in this question, in this case, it was I needed only one room. So times 13, people goes out of the room, and immediately that room is available for another party. So that's one thing I should have asked. But anyway, I will quickly wrap up. So in this video, I solved the question meeting rooms 2. And in this question, I was given intervals, which represent the meeting time interval. And my task was to return the minimum number of conference rooms, which is exactly the maximum concurrency of the meetings. And to get that number as my solution, firstly, I created the event list. Each event is the timestamp and also the diff of the meeting room count. Then I sorted it by the timestamps. Then I traversed each event and I kept track of the current concurrency. Then from those current concurrency numbers, I returned the maximum one. Okay, so let me finish my today's coding practice with this. Thank you so much. Bye.